So in this video we're going to look at the student's t distribution, and in particular its probability density function. Now I've got the probability density function written out here, and it's a complicated looking thing, it really is. Now it's given as f of x given nu, which is x is our random variable and nu is the degrees of freedom. So I'm going to write that up here. So nu is degrees of freedom and x is our random variable. Now the random variable for the t distribution, that's all the real numbers. So basically x is in the range of negative infinity to infinity. So it could take on any value. Now the degrees of freedom, that's normally 1 or greater. So let's write this one here. V is normally greater than 0 and it's always an integer. Okay, so what have we got here? So we've got gamma and nu plus 1 over 2. So that's a gamma function in our numerator. Now this bit here is some sort of constant which we multiply with our, basically looks like a function of x here, so of our random variable. And then we divide this by the square root of pi times our degrees of freedom, and then the gamma of our degrees of freedom nu divided by 2. And then inside here we've got even more stuff going on. We've got 1 plus x squared over nu to the power of the negative, so the reciprocal of this, nu plus 1 over 2. So let's look at a special case of our student's t distribution. So the t distribution is normally written as t given nu, so our degrees of freedom. So now let's set our degrees of freedom equal to 1. So it gives us a special case of our t distribution. So t of v. So let's set, so we've got t of nu equals 1. So that's going to give us our t distribution of PDF of f of x given nu equals 1. Okay, so now let's fill in all these values for nu equals 1. So now we've got our gamma function for 1 plus 1, so that's 1 plus 1 over 2. Divide that, so plug in 1 where we see our variable nu. So here we've just got square root of pi, so let's write that in there, square root of pi, and then the gamma of 1 over 2, so gamma over half. Okay, and then our function here with our random variable in it, we've got 1 plus our x squared over 1 to the power of minus 1 plus 1, obviously 2 over 2. So I'm just going to write that there as 1 plus 1 over 1 plus 1 over 2, sorry. Just going to put all that in there so we can break it down and see where we're going with this. Okay, so now let's bring this down and simplify it off. So now we've got gamma of 2 over 2, which is 1, divided by square root of pi, and again gamma of 1/2. So that's our kind of constant which goes before our random variable, simplified a little bit. And then here we've got 1 plus x squared. So the reciprocal, this denominator here is not needed. So we've got 1 plus x squared. And then we can raise all of that to 2 over 2. So that's to the minus 1. Okay, let's put a bracket around that bit there. Okay, let's simplify this off even more. So what's gamma of 1? So gamma of 1, our value for that is just 1. So gamma of 1 is 1. So we'll see that in our function there. And square root of pi, that will stay. And gamma of 1/2, let's write this up over here. Now I've done this in a previous video, so you can have a look how that is calculated if you like. But gamma of 1/2 is basically square root of pi. So we've got square root of pi times square root of pi. Okay, and now we've got 1 plus x squared to the minus 1, which is 1 over 1 plus x squared. Basically, it's reciprocal. Okay, well, square root of pi times square root of pi, that gives me 1 over pi and 1 over 1 plus x squared. Okay, so when our degrees of freedom is 1 with our t distribution, we've got this here for our PDF. Now this here is a really interesting and special case of a probability density function, which has got all kinds of properties which I'm going to show in the next video. But this here is our PDF when we've got a t distribution with 1 degree of freedom. Now what I'm going to do in a minute is I'm going to integrate this and just test that that is a valid PDF, because to go to that from all of this, there's a lot of things happened to that function there. So let's clear the board and integrate this and check it's a valid PDF. Okay, so let's check this is a valid PDF. So let's integrate it over its range of possible values, and hopefully we should get 1, and then we'll know it's a valid PDF. So let's go through that. So we've got x is from negative infinity to infinity, and we've got 1 over pi and 1 over 1 plus x squared. So we can write that like that and integrate with regards to x. Okay, now we can take the pi out of here. That's fine, 1 over pi, and then our parameters of integration remain the same. Okay, now this is an easy one to integrate because this is just a classic integral 1 over 1 plus x squared. We know that that's the inverse tangent of x, and we've got 1 over pi, which is our constant. So we can integrate straight away and put our result in. So we've got 1 over pi times inverse tangent of x, and that's calculated from negative infinity to infinity. Okay, so let's work out our values for that. So we've now got 1 over pi, and then we've got at infinity, so inverse tangent at infinity, and then we subtract our value at negative infinity, so minus inverse tangent at negative infinity. Okay, so let's calculate what we've got here. So the inverse tangent function, now let's just have a look at it on a graph. So the inverse tangent function will go along and it will have an upper bound, but not quite touching, of pi over 2 and minus pi over 2 for the lower bound. So pi over 2 and minus pi over 2. And at the intercept it will be 0. So it will take this kind of a shape, but never actually touching that asymptote there on the positive x-axis. So call that our x-axis. And then we're going this way, it will be the reverse of that. So it will come down and not quite touch our minus pi over 2. Let's see if I can make that a bit straighter. So it come down and not quite reach negative pi over 2, but it will go out forever and ever towards negative pi over 2. So now we can write our result. Let's write our result. Let's bring it up, clear the board and write it up here. Okay, so I've just written this up here like this for the result of our integration. So now let's fill in our values from using our graph. So we've got 1 over pi, and then we've got over 2. So basically I could have also written that. So the limit as x approaches infinity of the inverse tangent of x, that would also give me pi over 2. So that's also the same as what we've got here. And then we're going to subtract that, the inverse tangent of negative pi, which is negative pi over 2. So here I can write x approaches negative infinity, and I will get negative pi over 2. So now I've got minus pi over 2. Okay, so now pi over 2 minus pi over 2 is just pi. So now I've got 1 over pi times pi, and that's the desired result, which gives me 1. So that is a valid PDF. Now it's got a special name, this as well. This is basically a special case. It's called the Cauchy Distribution. Now it's got some very interesting properties which are very different from a lot of other distributions. So I'm going to go over those in the next few videos. So we're going to have a look at the variance, we're going to have a look at the mean, the mode, and we're going to also have a look at its higher orders as well. So its second moments of distribution and its third moments and so on. But there we go. This is what's called the Cauchy distribution. Okay.